everyone, welcome back. In this particular video, we will be discussing the problem string palindrome. What we are given is a string comprising of only lowercase alphabets, that is only alphabets from A till Z, only small a, small b up till small z. As given in the question, we don't have to take any other character into consideration. What we have to determine is whether it qualifies as a palindrome or not. That is, the string, is it a palindromic string or not? Now, which strings are known as palindromic strings? The strings is considered as a palindrome if it reads from same as forward and backward directions. That is, if you read the string starting from forward and the last index, that is zeroth index and last index, if it gets the same characters and you keep on reading the same characters in both the directions, it will be a palindromic string. How about taking example which is madam? So in case of madam, if you read it from left to right, that is forward to backward, it will be MADAM. How about backward to forward, or you can say right to left? It will still be MADAM. So this string only consists of lowercase alphabets and it is a palindromic string. So output should be true, or you can say yes, whatever the output expected is. If I take a string which is not necessarily of 5 characters, this was 5 characters. Maybe how about a string which is race car? So even if you take an example of race car, which is of 7 length, this was of 5 length, still this string is a palindromic string. Why? If you read it from left to right, it is RACECAR. If you read it from right to left, it is still RACECAR. Similarly, here it was palindrome. But it is not necessary that the palindromic strings will always be of odd length, like the 5 length or 7 length. Not necessary. It can be of even length also. So if I take the example of n is equals to 4, the string of 4 length, and the string is ADA. I'm not sure how to pronounce this, but whatever it is, if you read it from left to right, it is ADDA. Even if you read it from right to left, it is still ADDA. So this string is of even length, but still a palindromic string. And you can take some strings on your own, not necessarily meaning something. Maybe if I take a string which is A, B, C, B, and then B, C, B, A. This string of 4 length, actually not 4, but 8 length will be, of course, a palindrome. Why? Left to right, ABCB, BCBA. Right to left, ABCB, BCBA. Same. So it is also palindrome of 8 length. So it doesn't matter whether the strings are of odd length, even length. And for that matter, if you will take some corner scenarios, what if a string is of 0 length? In the question, it should mention what should we do for 0 length string. As if you will read the last line, for the purpose of this problem, we define empty strings, that is strings of 0 length, as a valid palindrome. In this case, we can consider it also is a palindrome. The empty string is also a palindrome. For n1, let's say there is only one character, let's say only A. How about the string? Left to right it is A, right to left it is still A. So yes, this corner case is also a palindrome. So for length 0 or for length 1 strings, we can directly assure and we can directly say that those strings will always be palindromic strings. However, for strings more than 1 length, at least which are of 2 length, we have to do some iterations. We have to go to each and every character and check. So one brute force way which must come to your mind, or before actually discussing the brute force, let me just write some test cases which are not palindromes. A, B, C, B, C, B, C, A, or maybe C, B, C, A. Yeah, that's if I take this string. If you read it left to right, it will be A, B, C, B, C, B, C, A. If you read it right to left, it is A, C, B, C, B, C, B, A. So it is not same. It is not a palindrome. So the point which you can actually observe if you will try to write more test cases is, how about just creating a new reverse string, maybe using any of the inbuilt functions, or if you know how to reverse a string, just reverse the string, create a new string and reverse it. So if you have the original string, if you have the reverse string, then only thing remaining is to compare both of them. So a brute force approach, which not really takes into consideration the best time complexity, the best space complexity, will be to just reverse the string, that is create a new string and reverse it, and then compare the original string with the reverse one and then compare. So what will be the time complexity in order to do it? Since we are reversing a string of n length, it will take linear time. And since we are going to compare, again, it will take linear time. But since we are creating a new string, the space complexity will also be required as order of n, because we are not returning strings. We are only getting one string as input. If we are creating a reverse string, it should be considered as extra space. So this approach one will be linear time, linear space. But the point is, we can do it without even creating a new string, which is without even reversing the string. Actually, we can just find out whether it is a palindrome or not. This is a very famous technique which we are about to use. Given that we need to check the string from left to right order and right to left order, how about checking in both these directions in the same string itself without creating a new string? That is, what I will say is, let's take the example of race car. Given the race car, what is the string's length? It is nothing but 7 length. So what will be the indices? It will be 0, 1, 2, 3, 4, 5, 6. What I will do is, I will maintain a pointer to do the forward traversal, that is traverse from left to right. Initially, it will start from the very 0th index. Let's say this is a left pointer because it is starting from leftmost index. And another pointer which is going to do right to left traversal, or you can say backward traversal, so that we can check if forward traversal is same as backward traversal. And the last index is where the right pointer, which will do the right to left traversal, will start from. We will compare, is the leftmost character same as rightmost character? Then only reading left to right, reading right to left will be same. So right now, as you can see, yes, R matches with R. So till now, the string is a palindrome. Next, which pair do we need to compare? After comparing the 0th index with the last index, that is 0 with n minus 1. Now we have to compare the next index left to right and the previous index right to left. That is, left pointer should get incremented by 1 and right pointer should get decremented by 1. So first we compared left and right character by initializing them as 0 and n minus 1, where n is the number of characters in the string's length. We compared if both of them are same or not. If they're not same, then we will do something. But right now, since they were same, we made left pointer increment by 1. We made right pointer decrement by 1. And again check, is left most character same as rightmost character? That is, forward traversal is giving the same string as backward. Yes, A is same as A. And right now, you don't have to consider uppercase. So it is just simply just checking whether they are equal in terms of ASCII code. That is, just you can simply use double equals to operator. Still, since it is same, increment the left character, decrement the right index, because now you will have to compare the third character from front to the third character from back. That is left plus plus, right minus minus. C is the same as a C. So still RAC is the same as RAC. You will still do left incremented, right decremented. Now at this point, what you are seeing is left and right pointer both are reaching to the same index. And when both the pointers reach to the same index, if you will compare, obviously they will give you the same character because they are same index. So what is the character at left? Third index character E. What is the character at right? Third index character, which is again E. So actually, if half of the string in the left is equivalent to half of the string in right in opposite direction, you no need to compare now the remaining points, because obviously if RAC is the same as RAC, you can also say ECAR will be same as ECAR. Obviously they will be same, because at this point we are just going to iterate over the remaining characters again, just in opposite directions. So at the point when left has reached to the same index as right, we can stop. So most probably what we are thinking right now is of a while loop, which will start from left as the 0th index, right as the last index, the n minus 1th index. Both of these pointers will run till the point left is not reaching to right. So let me just write some symbol, some question mark. We are not sure whether not equal to will be a right operator or not, because there are other scenarios which we have to take. This was a string of odd length, but we also should take care of even lengths, because in even lengths it might be possible that both pointers will not reach to the same index. We will compare the characters present at the left. The left character should be compared. Characters comparison will be made. We will write the logic obviously in the pseudo code itself, that is the instruction manual. Based on some logic, if they are same, then what we will do is we will increment left by 1. We will decrement right by 1. Left plus plus, right minus minus till some point. Now let's take the even scenario, and let's also we will take some scenario where the characters are not same. So, or you can say the string is not palindrome. This was a palindromic string because left reached right without none of the characters non-matching. So if I take the string which is A, B, C, B, B, C, B, A, this is zeroth index, first index, second index, third index, fourth index, fifth, sixth, seventh. As you can see, string is of 8 length. The left pointer, as discussed, will start from zeroth index. Right pointer, as discussed, start from last index. I'm just writing L and R for now. Compare the leftmost character with rightmost character. Are they same? Yes, A is the same as A. So till now it is a palindrome. Since till now it is a palindrome, left increment by 1, right decrement by 1. B is the same as B. Still it is a palindrome. Left incremented by 1, right decremented by 1. C is the same as C. Still it is a palindrome. Left increment by 1, right decrement by 1. Right now left and right are not same indices. Although they are same value, but it is 3, this is 4. B is the same as B still. It means A, B, C, B is the same as A, B, C, B. So half of the string in the left is equivalent to half of the string in right in opposite direction. It means the entire string is palindrome. Because now as soon as you will make left increment by 1, right decrement by 1, at the same point, what will happen is left will reach 4, right will reach 3. And now there is no point to compare again BCBA with BCBA. Obviously, it will be same if ABCB is same as ABCB. So at this point of time, when even left is not equal to right, but it is more than right, it has crossed right, it has went to the right side of right pointer, still we have to stop. So what are the two scenarios when we have to stop? Either left becomes equal to right or when left becomes more than right. So what should be the condition which we will provide inside the while loop? Should we provide the stopping condition when we have to stop the while loop? No, we will provide the condition till the point we have to run the while loop. And what is that condition? It is till the point left is smaller than right. Left was 0, right was 7. We will run the while loop. That is, we will make comparisons. 1 is less than 6, make comparison. 2 is less than 5, make comparison. 3 is less than 4, make comparison. But as soon as left is more than right, stop the comparisons, stop the while loop. That is string is a palindrome, confirmed. Similarly for the previous case, 0, 6, make comparisons because left is smaller than right, left is smaller than right, left is smaller than right. As soon as left is equal to right, stop the while loop and say that string is a palindrome. But just let's confirm that what do we have to do for returning? When should we return true? When should we return false? Should we return true inside the while loop or should we return true outside the while loop? Similarly for the returning false. Let me just copy this code again and let's just see what should we do for a test case which is not a palindrome. So let's say A, B, C, D, C, D, B, A. This string, if you will see carefully, is not a palindromic string. So what we are doing is having a string of 8 size, left pointer going to start from 0th index, right pointer going to start from the last index. Compare very first character with the very last character. They are same. Till now string is a palindrome. So till now you should not say that return true, that is answer is true, it is a valid palindrome. No. Till this point, yes, it is true. So don't just have a condition that if left character is same as right character, return true. No, it will return true just by one comparison. Instead of doing that, what do we need to do? Let's see. So we will increment left by 1. We will decrement right by 1. We will check. Is the leftmost character same as rightmost character? Yes, still. But still the entire string is not a palindrome. Left increment by 1. Right decrement by 1. Is the entire string palindrome? C is not equal to D. And at this point of time, if any two characters in a pair are not matching, it means A, B, C read from left to right, A, B, D read from right to left. If it is different, string is not a palindrome because definition is invalid now. So what we have to do in the checking part is not for equality, but for inequality. That is, if character at left, I'm just writing CHL for character at left. Obviously, you have to use some square bracket or use some functions to get the character from an index. If it is not equal to what the character at right, then you have to for sure say return false. Then for sure the string is not palindrome. But if all the characters from left to right are matching as right to left, after the while loop is the point we should return true. After the point we were having the left pointer more than right or left pointer equal to right, then we can say answer is true, not inside the for loop. And now, since all the three scenarios, positive test cases with odd even length and the negative test cases, all three of them are covered, let's now write the instruction manual of the better approach. And why is this a better approach? Because time complexity, as you can see, it is still linear. We are still running a loop over the entire string using two pointers, both pointers in worst case moving n by 2, n by 2, where n is the string size. So it will be n by 2 plus n by 2. Overall time will be n only, linear only, same as reversing a string. But when it comes to the space complexity, we are actually not taking any extra space. We are just making two pointers run over the input string itself. So constant space solution. That's why we are optimizing in terms of space, not in terms of time really. So let's do what? Let's erase all of this and let's write the instruction manual. The instruction manual will always be independent of any programming language. That is, I will set variables, I will set pointers, whatever you want to say, iterators, pointers, variables, because these are just integers. Left initially as 0th index, right initially as the last index. That is strings length -1. Important is -1, not strings length, not n, but n -1 if n is the string's length. Run a while loop till the point left pointer is smaller than right pointer. As soon as left becomes more than right or equal to right, then you have to print true. That is, after the while loop, you have to return true or print true, whatever. If we are having left smaller than right, then what we have to check is the leftmost character not equal to the rightmost character. If character at left is not same as, is different from character at right, it means the string is not a palindrome, so return false. But if they are matching, then how to check for the next pair? By incrementing left by 1 and decrementing right by 1. That is left plus plus, right minus minus. So this will be the entire two-pointer technique logic for solving or checking whether a string is palindrome. We will be writing the code for the problem string palindrome. So let's do what? Let's create a left variable starting as 0. Let's create a right variable starting as strings length -1. And in Java, how to take the string length? It is length function -1, because the very first index is not the one index, it is 0th index. Very last index is not nth index, it is n minus 1th index. Compare the characters till the point left is smaller than right. As soon as left becomes equal or more than right, we have to stop. But very important thing which we discussed already in the approach is we don't have to compare for equality inside the loop, but we have to compare for inequality. That is the character, how to take out a character from a given index in string in Java. It is using char at function. So strings character at left, if it is different from strings character at right, obviously this comparison will be made on the basis of their ASCII codes. If the characters are different, then there is no, it is not a better choice to move further and compare further pairs of characters. It is better to return false directly from this point itself. Returning from a function means popping that function. We have got the answer. But if it is not the if condition being true, then we can continue the iteration. And since there are two pointers involved, it is not just index plus plus, but rather left pointer plus plus, right pointer minus minus. And as discussed, when we have reached the half of the string, almost both the pointers have traveled till the same point, then we can say return true. The string is a palindrome. So hopefully it should work for every kind of scenario, whether the string is even length, odd length, and not a palindrome at all. Let's see. It is taking some time to run. Most probably for madam, it is giving me true. For odd length, let's just take it for the even length string. Maybe let's take A, B, C, D, D, C, B, A, which is a palindrome, but of even length. Let's see if it is going to work or not. And this is how you should actually do a dry run by your own in pen and paper to test whether it will work for different types of test cases or not. Let's just change the order of characters and make it a non-palindromic string. In this case, it should give me false. Let's see. And just to ensure that will our code work even for 0 length string and 1 length string, you can see if let's say the string's length is 0, left pointer will be 0, right pointer will be 0 minus 1, string's length will be 0, empty string. That is -1 only. And in the very first comparison, if you will make, is left less than right, is 0 less than -1? No, 0 is not less than -1. So stop the while loop, that is do not run the while loop at all and return true. Yes, we can say zero length string will be a valid palindrome according to the problem. And what if the string is of one length? In that case, left will be 0, right will be 1 minus 1, which is 0. Is 0 less than 0? Again, no. So again, loop will not work. We will again return true. So for 0 length strings, 1 length strings, both strings will work. As you can see, for invalid test case, it is working. Let's just confirm for a single length string. That is only A, only single character is there. And then we will submit it. So it is taking some time to run, but as you can see, it is accepted for that test case as well. If we will submit it, hopefully it should work for all types of test cases. All the 17 test cases are true or correct. And as we discussed, the time complexity is linear. Why? Because we are running the loop over the entire string using 2 pointers, which is n by 2 times iterating. So order of n or linear time and constant space, because we are not taking any extra data structure, any auxiliary data structure. So that was the problem. String palindrome. Now we will meet in a new video with a new problem. Till then, bye bye. Take care.